Hey problem solvers, Colfax Math here. Today we're going to talk about the derivative. You've actually been working, building up to this point in high school math for maybe 10 years. And it's such a big idea and has such big impacts on the way we do science and engineering in the world. And it's really not that big of an idea, but it is life-changing. So the derivative is really just the slope of any line at any point. So slope could be represented as m, rise over run. And we talk about rise as a change in y values. So it could be the change in y, like y2 minus y1, over a change in run, x values, x2 minus x1. You could call that the change in y. Delta is used as change, so that's the change in y over the change in x, or delta y, delta x can be abbreviated dy dx. Let's just quickly look at a linear function, then we'll look at a parabola. So the slope here is rise. How much do I rise over how much do I run? Well, 3 minus 1 is 2, so the change in y is 2. The change in run, 1 minus 0 is 1. So m here is equal to 2 over 1. That's the slope. If I had an equation for this, it would be y equals 2x plus 1, where m, 2, is my slope. The derivative of this linear function, sometimes using prime to say the slope of this function, is equal to 2. Okay, let's take a look at a parabola now. Let's say I have this function here, y equals x squared, or f of x equals x squared. Again, horizontal, vertical axes, and I can see the slope is changing. Here I have a negative slope, right, of a line of tangency to that graph. And that line of tangency is going to keep changing as I move along that graph. That negative slope finally becomes 0, and then it starts to become positive. So I could draw this line of tangency and approximate the slope between here and here. I could just assign this and just call this some point x. And this point right here could be some other point, x plus delta x, x plus the change in x. I'm actually just going to call this length here h and say this point is x plus h. The corresponding y value of x, this corresponding y value right here, would be f of x. Therefore, this corresponding y value would be the y value to that point, f of x plus h. So now I have 2 points on my curve, and I could say they're getting closer and closer. So rather than have a secant line like that goes through 2 points, I'm actually looking for a tangent line that's going to get closer and closer. So I could bring these things closer and closer, and I could start to say this h value is closer and closer to 0. And that's going to be a limit. So the definition of a derivative is the limit as that horizontal distance h approaches 0 of y2 minus y1, f of x plus h, y2 minus y1, all over run, x2 minus x1, x plus h minus x. And then here's my function, f of x equals x squared. So my function f of x plus h, well, wherever there's an x, I now plug in x plus h. So this is equal to the quantity x plus h squared. So I'm going to take this value of f of x plus h minus this value over x2 minus x1. So it is still a limit as h approaches 0. I have x plus h squared minus x squared all over x plus h minus x. My x's cancel, and I have an h on the bottom. I need to expand this out right here. The limit as h approaches 0 of x squared plus, remember I have to FOIL this out, x plus h plus x plus h, 2xh plus h squared minus x squared all over h. Now that I have that, I'm going to simplify a little bit here. So I have x squared minus x squared. So it's the limit as h approaches 0. I have 2xh plus h squared all over h. I have that common term of h, so let me factor that out. The limit as h approaches 0, factoring that h out, I have h times 2x plus h all over h, right? The check of that is distributing that h through the quantity. 2xh plus h squared is that. Now that I've done that, these h's will cancel. I could do the limit as h approaches 0. I'm going to plug that 0 in here, and that's going to give me 2x. So the limit as h approaches 0 for this function is 2x. And that is the derivative, the slope of this function. And it kind of leads us to the chain rule. And the chain rule is, if you were to ask to find the derivative, sometimes use the prime, of the function x to the n, well, x to the n, the rule is you bring this n down in front and you subtract 1. So the chain rule is, if you have a function x to the n, the derivative of that function is nx to the n minus 1. So if your function is 2x to the third, the derivative of this, y prime, bring this down in front, 3 times 2 is equal to 6, x to the 3 minus 1, 2. That's how easy it is. But the most important thing is that you understand where it comes from with the definition of the derivative.